Oh, hi there. Thanks for showing up for your learning. This time we're looking at our rational number skills. So these rational number skills are really going to take our abilities with integers and apply them to more complex numbers that are comparing two different numbers. Now we're going to have numbers living upstairs and living downstairs, and we're going to find it's very useful because there's a number of tricks that help us organize our work and make quick work of challenging problems. And that's what we want to do, is build those skills so that we're comfortable with all different types of problem types, so that we're ready for various things that are going to be thrown at us in future classes and future careers. So again, the way you use this video is I'm going to show problems, and then you're going to pause the video when we're looking at the problem. I'll solve it, you pause and then you solve it. And then if you get stuck, unpause the video. Or if you solve it, unpause the video and check it against my solution. You can also dive into Delta Math and practice. And if you run into problems, drop into this video using the timestamps so that you can see an example being completed for you. All right, let's go. So, okay. First skill, finding unit rates. So this is very useful, and there's two different ways that we're going to practice it here, finding unit rates. So let's go. Okay, so this one, if Maisha reads 3 books in 12 months, what's her rate of reading in books per month? Okay, so what we do with these ones is we have here 12 months, 3 books. That's the ratio, and we can visualize it. Absolutely, you want to be doing these types of things, like visualize like 12 calendar pages, 3 books. So that'd be like 1 book every 4 months, right? Because that would be 3 books in a year. And then here, you take this one and you just scale it down to the 1. That will give us that's books per month, is 1/4 of a book she reads per month. So she reads 1/4 of a book per month. We submit it. Hooray! Let's do another. Okay, Wyatt walks 8 miles in 2 hours. What's his walking rate in miles per hour? So 8 miles, 2 hours. We want to resize it so that we get miles per hour. If I resize this down, you see what happens. If I resize up, you see the ratio between those two things stays the same. If they go to 0, they'll both be 0. Oh, we can't show you 0. That's 2, that's 3, that's 4, 5 hours. Here we go, 20 miles. You see, but there's our unit rate, 4 miles per hour. So we resize and figure it out. So it's a very useful visual tool, and you can imagine like scaling things up and down in your mind. I do this all the time, and it's very useful to like estimate things and solve problems. So, and it's also, you're going to see we do this a lot in some other things that are coming up. So we got miles and hours, lawns and hours, books and months. Let's do bananas and dollars. Bananas and dollars sounds fun. Ariana bought 10 bananas for $5. What's the cost of bananas in bananas per dollar? Okay, let's go to $1 here. So if we went up to like $6, see 12 bananas, $7, 14 bananas. You can already see it. $1, 2 bananas. 2 bananas per dollar. Try these. They're fun, and they'll build your understanding so that you can then show me that you got this understanding. Next, we can go unit rate, reasoning down. Okay, these are cool problems too. All right, so here's another way to visualize these. If Owen earns $370.60 at his job when he works for 17 hours, what did he earn in 1 hour? So what I can do is put in here like $17 and 370.6. Okay, so that's how much money he made for $17. And I want to know, what about 1 hour? Okay, and so when I want to know that, I actually can use division here. And this actually sets up my numbers in the way I want to have them organized to like set up a nice fraction. So let me show you. Okay, if you build them as fractions, this will be true, right? 370.6 divided by 17 will be equal to some amount of dollars divided by 1. Okay, so if I just do this division, it's going to give me the amount of dollars that he makes. Cool. So let's do that. At this point, you're going to see me get out a calculator because I don't happen to know 370.6 divided by 17 off the top of my head. It's kind of an ugly question. You kind of need a calculator for it, or do it longhand. 0.6 divided by 17. That's what that fraction bar means. It means divided by. He makes $21.80 an hour. So I can put that in there. $21.80. The answer is 21.80. Hooray! Let's do another. A grocery store sells a bag of 8 oranges for $4.48. What's the cost of oranges in dollars per orange? Okay, so here's how you do these. Again, we're going to find the unit rate, the cost for one orange. You put the money on top, $4.48. You put the number of oranges on the bottom, and that's going to give us, I think I can do that one in my head. Maybe I don't want to. 8 divided by 8 equals 56. So it's 0.56 because I didn't put in my decimal place. That's why. I'll show you. 4.48 divided by 8 equals 56 cents. Okay, so that's how much an orange costs. Now, something I should have mentioned is when I'm doing these, I'm still visualizing those like ratios as they go up and scale down, or I'm imagining $4.48 and I stretch it across 8 oranges, and then I associate a group of money with one orange to find it. Guess first. Absolutely guess first at these unit rates. And that's going to build your guessing power. And it's also going to help you check and see if you got the right answer. Like when I got 56, I knew that meant 56 cents. I knew that couldn't be $56 per orange because, I mean, look at it. I'm not paying $56 for an orange, first of all. Second of all, I paid a little less than $5 for 8 of them, so I should pay a little less than $1 for one of them. You see? You see? Yeah, so that's kind of what we're up to there. So that's the skill of unit rates. Super useful. You're going to use this a lot in life. You're going to use this this is absolutely grocery store math. We want to be able to get the best deal. So you want to know, should I buy the bananas in a bunch or individually, whatever. Okay, next skill, using proportional reasoning. These are awesome. And again, very, very useful. So for these ones, finding the unit rate is one of our steps. Okay, there's one way to do it, which is multi-step, and that's what I'm going to show you. And then there's a way that I'll teach you later if you get really good at this. First, find the unit rate. So if we know that she goes 462 miles on 11 gallons, this will give us the unit rate for number of miles she goes on 1 gallon. So 462 divided by 11 happens to be 42, because I can do that division in my head. You can't, so you'll use your calculator. Who do I think I am saying you can't do that in your head? Prove me wrong. Do it in your head. I'd like to see you try and fail and then try and succeed, because that's the way growth works in math. First, you often fail, and then you learn to do it correctly, and then you succeed. You can do it. It's not that hard. It's 42 miles per gallon. Okay. And now we want to know about 14 gallons. How far will she go? This is the question that we want to answer. And so I just multiply that by the unit rate, because she goes 42 miles per 1 gallon. And so doing this multiplication will tell me how far she goes on 14 gallons. And I don't really want to do that in my head. I can, but I don't want to. 14 times 4 to 2 equals 588. 588. Yeah, so this is proportional reasoning. And here's another thing that you want to do with delta math is read their explanation. Method 1, first, find how many miles the car goes on 1 gallon. Divide by 11. Divide by 11, sure, go to 1. 42 miles per gallon. Use this to find, and then we multiply. That's exactly how I did it. But they have a more beautiful visualization for it, and you can start visualizing it in their way if you like. Activate the visual component of your mind, and you'll understand math the same way you understand people's faces. Like, you forget people's names, but you can remember their faces. Well, sometimes I forget how to do a math problem, but I can remember what it looks like. And if I can remember what it looks like, sometimes that's enough to piece together a method to solve the problem. Okay, so try it. Set up a proportion and solve. Yeah, this is the method I said. There's another way. I'll teach you later if you figure out the first method. This is how I would do it. And you can do it however you like. Let's go. Should we do another one? Absolutely, Mr. Jennings. Let's do another. Because you're having so much fun, Mr. Jennings. I don't want you to stop when you're in the middle of having so much fun. Okay, so Tyler bought 8 chicken wing for 16 buccarinos. And if Tyler spent 46 bucks, how many chicken wings did he buy? Oh, well, he bought 23 of them. And let me show you how I know that so quickly. So we know, first I find the unit rate. $16 for 8 chicken wing. So this proportion is going to tell us how much each chicken wing costs. Okay, that's 16 bucks for 8 chicken wings. So that tells us that it's $2 per chicken wing. Okay, the chicken wings cost $2 each. And then I know that Tyler spent 46. Oh my goodness, that's Mr. Young calling me. Lots of interruptions this question. Thanks for your patience. So if they spent $46 total and each chicken wing cost $2, then we can use division here to find out how many chicken wings they bought. Okay, that gives us 23 chicken wing. Cool. So put it in. The answer, 23. Hooray. So that's what that looked like when you do it. Okay, so those are great questions. You want to practice them. Percent of a whole and decimal percent of a whole, and which is more? Percent comparisons and percents. So let's take a look at percents. And we're going to do rapid fire on these skills. You want to know how to do this. It's not as important for your grade 10 success, but you should know how to do this. So let's go. Percent of a whole. 416 is what percent of 800? This is what you do. You know that it's less than 100%. So you set up your fraction, 416, the 416, over 800. I know this will be less than 1. Okay, I know that because the smaller number is on top, the bigger number is on the bottom, right? That's like cutting a pizza into 800 slices and you eat 416. Okay, you ate 52% of a pizza. Oh my gosh, he knows how to do that in his head. Yes, I do. And there's a trick there, and I'm not going to teach you the trick. You're just going to use your calculator to find that that's 0.52. So I told you it was less than 1, right? And it is indeed. That is a number smaller than 1. It is 0.52, and we want to be able to convert that to a percent. To do that, you just move the decimal place over. That's 52%. Now, something I forgot to mention, but it's something you always do, is you always start with a guess. I see 400 and a bit divided by 800. It's ever so slightly more than 50%. If there are 800 questions on the test and you got 416 right, well, I would be saying, why'd your teacher put 800 questions on the test? But after I was finished saying that, I would say, well, I mean, where'd the other 48% go? Anyway, whatever. It doesn't matter. But yeah, that's how you do that. So answer is 52%. Cool. So that's how you do those. Remember when I said I was going to go through these quickly? Yeah, let's go quickly. Decimal percent of a whole. So if we want to find the percentage of a number like this, then we actually use multiplication. You want to know how to apply percentages. This is one of our operations with rational numbers. So if I want to have 30.2% of 496.8, then what I do is I convert that to a decimal, 0.302. To convert percent to a decimal, you just move the decimal place 2 in that direction. So there's a leading 0. We have the decimal place, and then we have 0.302. We can remove this percentage sign when we do that. It's no longer percent. It's now a decimal. It's been converted to another form. And then we just use multiplication. We multiply by 496.8, which happens to be, I don't know, but I start with a guess. So let me show you how I would guess. This is pretty close to 30%. This is pretty close to 500. So I am predicting that we're going to have somewhere around 148. It's going to be very close to 150, but slightly lower, I believe. 30.2. Oh, sorry. Clear. 0.302, that's better, Mr. Jennings, multiplied by 496.8 equals 150.0336. Now they asked for to the nearest thousandth. Okay, so we need to round to the nearest thousandth. And that has tens. I'll write it down here. 150.0336. It has tenths, hundredths, thousandths. Those are the names of the different places. This is the 10,000ths. Because this is bigger than 5, it will round that one up. So the number I'm going to write into Delta Math is 150,034. Because the 3 rounds up because the 6 is bigger than the 5. 150.034. Ha ha! My goodness. Gracious me. He got it correct using the calculator. It's amazing. Okay, let's keep going. All right, decimal percent of a whole. Which is more? Percent comparison. These are fun. In art class, students are mixing blue and red paint. So Tashawn is mixing 5 cups of blue paint and 3 cups of red paint. Okay, so here, let's just get ourselves some blank space on our page. I'm going to go up a bit. So here's Tashawn. What? Tashawn. He's going to use, we want to know whose purple paint will be redder. So let's figure out what percentage of Tashawn's paint is red. So I would say 3 cups of red paint divided by how many cups total? 5 plus 3. This is the total number of cups that Tashawn is using. So he's using in total 8 cups. 5 are blue and 3 are red. So 3 out of 8. So when I do that, well, that's still a Bedmas problem. I have to do the addition on the bottom first because there's actually a set of invisible brackets there. Okay, so when you're working with a fraction, evaluate the numerator, evaluate the denominator as though they're in brackets. That's an important Bedmas point. And then we do it. 3 divided by 8. So 3 divided by 8 happens to be 0.365. 3 divided by 8, I forget. 0.375, of course. 375. What's 65? Geez, 365 days in the year, but not in me getting that correct. 0.375. Okay, so the percentage of his that's red is 37.5. It's 37.5% red. Because notice I just did that little trick as though it's easy for me to move the decimal place twice. And it will be easy for you too, as long as you practice. Okay, Catherine mixes 10 cups of blue paint and 9 cups of red paint. Well, hers is way redder. I'll show you. Why do I know right away? I visualized. Use visualization. I happen to know she has 45% of red paint. Okay, so here's Catherine. So Catherine used, no, I was wrong actually. 9 cups of red paint divided by 9 plus 10. So it's not 45%, it's even higher. Okay, so 9 divided by 9 plus 10. So that is 9 over 19. That's a little bit less than half, but ever so slightly less than half of her paint was red. Sorry, that was my son. He wanted to rickroll his sister. So if there was ever a good reason to interrupt your father making a math video, that was it. All right, so now we just do the division, right? 9 divided by 19 is going to be like 47 point something gross. 47.3684210526315789473684. You see the repeating pattern in there? There is a repeating pattern, but it is gross. Remember, and I remember I guessed it. I start with a guess. See how good my guess was? It's like 47% here. Pretty cool. And to the nearest whole number, his percentage to the nearest whole number was 38, because to the nearest whole means round to there, and the 5 makes the 7 round up. So his paint was 38% red, and her paint was 47% red. Tashawn's purple paint will not be redder. It's Catherine's. So this is how you could use percents to analyze like stuff like that. So cool, right? I think it's cool. Anyway, it's one interesting application of that. So let's take a look at some percent word problems next. Okay, level 1. Tanisha earned a grade of 82% on her multiple choice math final that had a total of 200 problems. How many problems on the final exam did Tanisha answer correctly? Okay, here. I've been saying over and over, right? Start with a guess. So here, if you know that there were 200 questions on the exam and she got less than perfect, but pretty good, like an 80, that's good. You got most of the questions. Good. So if you got most of the questions, it's going to be more than 100, right? 100 and you got a 50. 200 and you got 100. So can we agree that the answer will be between 100 and 200? Like start with a guess. Maybe like 150, maybe even a little north of that, like 164. Oh, that'd be a very good guess, 164. And then here's how you do it. 200 total questions, multiply it by 82%. But then we're going to convert that percent to a decimal. Still 200 questions multiplied by 0.82. Then we do that on the calculator. 200 times 0.82 and get, oh my goodness, 164. 164. That's amazing. It's just amazing. So that's how you do those. Let's see the next level. Harper surveyed 800 of the students in her school about their favorite color. 424 students said their favorite color was blue. What percentage of the students? Is this not? It's very close. It's very close to the question we had before. The answer is 53%. Okay, but you're going to start with a guess. And your guess won't just jump to the correct answer like I am. My daughter just came down to say she appreciated being rickrolled. All right. So we have to calculate a percentage, and we start with a guess. A little more than half, right? Because there were 800 in total students, and we had a little more than half of them, 424, chose blue as their favorite color. And I agree. If I were there, it would be 801 people they surveyed, and it'd be 425. As you may know, blue is my favorite color. So let's go. We do this on our calculator, and we start with a guess. 400 would be half of 800. So I'm expecting a number a little bit bigger than 50%, like, oh, say 53%. So we have 424 divided by 800. So 53%, very good. So that's 0.53. It's not percent yet because I have to move the decimal place twice to make it percent. That's just the decimal number, where 1 would be 100%. Okay, now, why do you want to start with a guess? Well, supposing you did this, 800 divided by 424, and got this as your answer, 1.88. You might say, oh, I don't know, was that 88%, 89%? What happens at 1? I don't know, 188%? And because you didn't start with a guess, you're not like, oh, I must have made an error when I punched that in my calculator. Your calculator doesn't know what you want. The calculator did the math right, but you did the math wrong if you did that. With a guess, you'll know right away that that's incorrect, and you'll fix it. You'll divide them the other way. And that's how you build your abilities. Start with a guess, do the calculation, work with your guess. Okay, so that's percentage. I'm 100% sure that's correct. Good. Let's go. Okay, now we get to multiplying and dividing fractions. All right. Oh, and I wanted to have this one be up here like that so that they're together. Yeah, so you'll see those. All right, so let's take a look at how we multiply and divide fractions. So I'll do some examples. I think I probably have some examples on the sheet, so let's go to the sheet. Gosh, I might as well use the sheet, right? Which is more percent comparison. We did all those. Here we go, multiply and divide fractions. So let's take a look at these. Some specially selected examples for your enlightenment and edification. Here we go. So when we do multiplication of fractions, this is our procedure. We just have 5 over 8 times 2 over 3. This is the same thing as 5 times 2 over 8 times 3, okay? And then we do that. 5 times 2 is 10. 8 times 3 is 24. And then if I put in 10 over 24, it's going to tell me, that's not it, because they both share factors, okay? I can write 10 as 5 times 2. I can write 24 as 12 times 2 because 2 is involved in both numbers, the factor 2, it can cancel and give me the simpler fraction 5/12. So that will be the correct answer. Do you want an easier way to do it? Yes, Mr. Jennings, give us the easier way. We really want an easier way to do this. Well, I'm glad that you are still showing up for your learning and still with me. Here I notice a 2 living upstairs and a number that's divisible by 2 living downstairs. I do this division, and 2 divided by 8 is the same thing as 1/4. So that's a 1 there now. I just divided both those numbers by 2. Then I do 5 times 1 equals 5, and 4 times 3 equals 12. 5/12. That's how you do it.
Hello.
The kids are getting Netflix. Okay, so that should avoid any future interruptions. Okay, so that is multiplication of fractions. We just do top times top over bottom times bottom. Division is one step trickier, that is to say, not particularly tricky. Okay, let's take a look at this division question. We've got 4/3 divided by 5/3. All right. When you've got this type of situation, the one you're dividing by, that will be the one after the division sign or the one underneath on the division. You just take that and flip it, and then it becomes a multiplication problem. So this is 4/3. This one is keep, and then we flip this. So that's 3/5, and it changes to multiplication. Okay, so now you can go ahead and do 4 times 3 on the top, which is 12, and 3 times 5 on the bottom, which is 15. And then notice that both of those are divisible by 3, so you've got 4/5. But you didn't need to notice that both of those were divisible by 3 because you were multiplying both of them by 3. You could have canceled these 3's here, okay? Because you got a 3 living downstairs and a 3 living upstairs. And whenever you've got that situation, go ahead and cancel. Don't multiply them in. You're just making more work for yourselves. And then you just got 4/5. Answer. Bam. Bam. Okay. And then there's a harder version of each one of these. Here's the harder version of multiply fractions, where we got 5/4 times -10/3. And then the thing we learned in integers about multiplying negatives applies here. Because we have one negative in the problem, the answer will be negative. So this is equal to negative, put it in brackets, 5 multiplied by 10 over 4 multiplied by 3. I can hear some of you saying, where did that negative go? Was the 10 negative? Was the 3 negative? Or was the whole thing negative? Okay, you're all asking the wrong question. The answer is going to be negative because you're multiplying a positive thing by a negative thing. So just know that the answer is negative and do the multiplication. It's the easiest way, I believe. And then we go ahead and do that. Here is a cancellation that's available. It's a little bit hard to spot, but it's not that bad. 10 and 4 are both divisible by 2. So when I divide them by 2, that's going to be a 2 and that's going to be a 5. So then on the top of that fraction, we're going to have 5 times 5, which is 25. And on the bottom, we have 2 times 3, which is 6. 25 and 6 don't share factors, and the answer is negative. So that's the answer. That's how you do those. Multiplying is fairly straightforward. I hope you'll agree. Dividing, on the other hand, has that one flip, and then it becomes a multiplication question. So this will look like this. I rewrite it like this. Equals, keep the top one, -2/3. Multiply by the bottom one, flipped, 7/10. Holy goodness, same cancellation we just had. That cancels to 1. The answer is negative because I got one negative in there, and I have a 7 living on top multiplied by 1, and a 3 times 5 on the bottom is 15. There's your answer for that one. This is effectively saying how many times does 10/7 go into -2/3? It goes in -7/15 times. I mean, I'm not here visualizing or really starting with a guess that much. Okay, these ones just practice the algorithm and learn the algorithm. By the algorithm, I mean the method by which we solve these things. I mean, I love understanding this stuff as much as the next person, but okay, addition and subtraction of fractions is actually more challenging than division and multiplication because there's that extra step of needing to create a common denominator. So I want to show you how to use the wipeable boards that we developed for this program. So I'm just going to open up a copy of the wipeable board, make it a little smaller, and then we're going to go over here and get a fresh Delta Math problem. And then I'll show you how to do it without the boards. Adding and subtracting fractions when they're positive. Great. Positive fractions. What could be better? 1/12 plus 7/8. So here's what we do. We go ahead and get our pen on. So get your wipeable pen, like what I have here. Move your face if your face happens to be in the way of the question. And copy down the question. 1/12 times 7/8. And this is plus because this said plus here, you see? And now now that I've got that copied over, I can do my work here. 1/12, well, that's going to look like something like that, right? Like if I divided this into quarters and then divided each quarter into thirds, that would be 1/12. It means cut this pizza into 12 slices and keep one. How do I know that's 12 slices? There's 3 in that corner, 3 in this corner, 3 in this corner, and 3 in this corner, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Just like that clock that's on the wall. So that's 1/12, right? Or basically 1 o'clock of pizza. And then 7/8. Oh, 7/8 we can visualize like this. There's a half. There's a quarter. Here comes 7/8. There's now eighths. See, I've divided this up into eighths. And if I've got 7 of them, I've got all this. That's 4/8, 5/8, 6/8, 7/8. Okay, so I've got all that. I'm only missing this much pizza, and I have this to add in there. So I'm guessing my answer will be between 0 and 1, but be awfully close to 1. Like it really looks like this is almost enough to fill the gap. So I still have a gap and I need to create a common denominator. So what I do is I bring my numbers down. All right. So I'll just put them back in there. We're just in the same color-coded box where you put them up above. And then notice, here's your green box. That number goes here, 12 and 12. Okay, and here's your blue box. Well, that number goes over there, 8 and 8. And this will always create a common denominator. And it's, for my money, the easiest way to do it. So try it that way. Unless you got your fancy schmancy tricks to do it easier way. There is an easier way, but this one's the easier way. Easier for different reasons. So now I just bring these numbers over. 8 times 12. My calculator tells me that is 96. Okay, so I just go ahead and put 96 there. That's the result of multiplying these two numbers. Okay, and then I get these numbers here, 8 and 1. That's 8. So that number goes there. See, it's all color-coded for your convenience. And then 7 and 12. 7 times 12. My calculator tells me that's 84. Okay, so that number goes there, 84. And then we just do this. Oh yeah, but we're adding. We're not subtracting. So we have to change all these to addition. They're all addition, okay? Because, of course, we're adding those things. So this is 8 96ths plus 84 96ths. And now we have a common denominator. So let's do that. 8 plus 84 is 92 over 96. And now maybe I notice, wow, both of those numbers happen to be divisible by 2. So if I take the 2 out, that would be 46 over 96 divided by 2 happens to be 48. Wow, they're still both divisible by 2. So I take out another 2, 23 over 24. Oh, I predicted a number ever so slightly smaller than 1, and I got one, 23 24ths. Great. So that's how I would do that question. Oh, let's put it into Delta Math, see if it likes it. 23 over 24. Yay. And you can also, to break these numbers down and factor them, use the handy division facts cards that we have in class. Those you want to memorize it, but you'll memorize it by practicing. You're not going to memorize it by staring at the card. Okay, so let's do another one where we get a subtraction. There, 7 ninths minus 5 twelfths. So this is what it will look like. 7 ninths. Oh, we need to get our pen on. 7/9. So when I visualize that, I don't really get too fussed about it. It's like about like that, right? This is about 2/9 and this is about 7/9. Okay. I'll just visualize it as best I can. 7/9 minus, what's my question? 5/12. Love it. 5/12. Well, that's like 5 o'clock of pizza. So it's like that. Okay. So if I were to have this here, right? This much stuff, and I take that out of this, okay, subtraction would mean like removing that piece. So all that's gone, and all that we would be left with is this part. And so how big is that part? Well, it's really close to a half. It's between 0 and 1. So I'm expecting like about 0.5 or 1/2, something pretty close, maybe a little smaller than a half, maybe something like 0.3 or 0.4, somewhere in there is my guess. So we just do our stuff. You can just multiply by all the things. Okay, so we just bring our numbers down. 7/9, 5/12. This number goes over here, 12, 12. This number goes over here, 9, 9. And then we do the multiplications. 12 times 7. Okay, you can do it in the rough work corner if you want, or you can just know that that's 84 because your calculator told you, or because you know your 12 times tables. 5 times 9 is 45, and 12 times 9 is 108. Okay, so now the slice sizes are the same. Because we're subtracting here, this sign is correct. It's still minus, and this is still minus. Cool. 84 minus 45 happens to be 39 over 108. And then you use your factor trees and stuff to find that 39 and 108 are both divisible by 3. Okay. 39 happens to be 3 times 13, and 108 happens to be 3 times 36. And then the 3's cancel, piang piang, and we're left with 13 over 36. 13 over 36. Yeah, great. So let's plop that. And then we compare to our guess. Okay. Half of 36 would be 18. So we're a little less than half. Remember, a little less than half, everybody? And I feel good because I'm like, I imagined it would be about that. And then I found it was exactly that. And I like that feeling. So I want you to have that feeling. I want you to start enjoying that feeling because then your skills will go so high. 13 over 36. Oh, when you get that check mark, give yourself a pat on the back. It's very important. Very important step. Give yourself a pat on the back every check mark. Add and subtract fractions level 2. Okay, so let me show you how to do these if you're working on paper. Okay, if you're working on paper without you want to use the sheet when you're learning, but you also want to graduate from that so that you can do these yourself when you don't have the giant laminated sheet at your disposal. So here, I learned how to do this myself. Oh, this one is so easy. Let's do another one. No problem. This has the same denominator. That has the same denominator. That one has a different denominator. Let's go. Okay, so if I have... I want something a little different. That is good for my purposes, sure. Okay. Now, let's try this. Now let's go A over B plus negative C over D. Here we go. This is the type of question I wanted. All right, so this is their up leveling your skills, and we've got now positive and negative signs involved. Okay, so I'm going to copy out my question. 3 over 20. Is my pen like super fat? No, I'm just super zoomed in. Okay, 3 over 20 plus negative 9 over 8. I just copied out the question. That's all I did, and I checked my hand. It didn't fall off, and it still works. So don't be scared about copying questions out to work on. It's a great habit. I think it actually builds your math skills. So then we say this is equal to, well, I want to scale these up. So I'm going to go 3 over 20 plus, but plus a minus. Well, I can improve that. That's just minus, right? Adding a negative is just like subtract 9 over 8. And then I go ahead and get my build a common denominator pen out. because I like to do that with orange for no reason. Okay. And I'm going to take that number over there, 8, and multiply top and bottom. And this number over there, 20, and multiply top and bottom. I'm allowed to do that because you're allowed to multiply things by 1. They don't change. 8 over 8 is 1. 20 over 20 is 1. All right. And now we will get a common denominator. So I do these multiplications. Okay. 8 times 3 is 24. 8 over 20 is 160. Minus 9 times 20 is 180. And then 8 times 20 is 160. I forgot to start with a guess. I have something very small, something close to 0. I am subtracting something larger than 1. I will get a number that's negative, and it's probably going to be really darn close to -1, but not exactly -1. Okay, so let's go. 24 minus 180. So I can rewrite this, and you'll find that it's already rewritten. Like we skipped that step above on the sheet, and that's fine. Okay, so we go straight to that line. It's fine. And then 24 minus 180. Well, we've done our practice with adding and subtracting positive and negative integers. And if you want more practice, go ahead and do it. But here's how I do these. 24 minus 180 is challenging. So I turn it into this. I know it's the negative version of 180 minus 24. And then even with that, 180 minus 24, I split that into minus 180 minus 20 minus 4. I break it up so that I can do it in my head. That's negative 160, that's this, minus 4. Oh, now I just have one little thing to do where I have to, borrow one from the 6 or whatever. Minus 156. So that's my answer, negative 156. So it's equal to negative 156 over 160. And then if I can notice that both of these numbers are divisible by 4, I can do that. And I'm might do that on a calculator. 156 divided by 4 equals 39. 39, but negative, over 160 divided by 4? Well, 40. Okay. Remember I said really, really close to 1, but not quite 1? There it is, folks. Very, very close to 1 negative, but not 1 negative. Okay. So minus 39 over 40. That's how that one do. Minus 39 over 40. That's how that one do. Hey. Okay, so that's that level. All right, great. So now, if you want to go to a very high level, try these next skills. This will get you ready for like 10 academic and other like more challenging explorations in math going forward, things like grade 11 university. You'll want to be able to deal with compound fractions. These are like order of operations questions inside the context of fractions. This one is too easy. We're going to go with this problem type to start. I think, I copied some out for us, but yeah, let's do the ones on the sheet, and then I'll show you the ones that are in there. Okay. Oh, come on. Unzoom. There we go. I had some addition and subtraction of fractions questions I could have done there too. Whatever. Okay. So over here, compound fractions. Getting started on this skill. So this is a bedmas problem, and we have to remember that there's these invisible brackets around the numerator and denominator in these types of problems. So what we do is we just evaluate that first. I'm going to bring the top down. I rewrite it, 9 over 8. See, it's very tidy. And then I go over 1 over 2 plus 5 over 14. Well, I'm going to do some work on the question level. Watch me skip a step, everybody. 14 over 14. I'm going to multiply that there. 2 over 2. People see where I'm getting these numbers, right? Just from the opposite fraction. This will always create a common denominator. I know it's not the lowest common denominator, but do you think I really care about lowest common denominators? I care about getting right answers. And if this gets you to right answers, then I'm giving you this method, okay? So this one here is 14 times 1. That's 14 over 14 times 2, that's 28. Okay, and then we're going to be adding 5 times 2, that's 10, over 14 times 2, that's 28. Okay, and then we go equals 9 over 8, divided by 24 over 28. Okay, cool. And then you could reduce your fractions. You could notice that 24 and 28 are each divisible by 4 and take out that extra factor there. Oh, yeah. And that's actually a good idea. Let's do exactly that. So that's equal to 9 over 8. Notice that number on top hasn't changed yet. We haven't touched it, and that's fine. It just comes down and waits for to be operated on. And then 24 over 28. Well, when we divide both those by 4, we get 8 over 9. Sorry. No, we don't. We get 6 over 7. Sheesh Louise. 6 over 7. Yeah, even I make mistakes. But notice I caught my error. And you want to start catching your own errors too. When you start seeing that happen, that's when you're getting good at math. This is a divide by question. So when we divide by, we take the bottom one, flip it, and multiply. So this is just 9 over 8 multiplied by 7 over 6. And now, folks, there's a cancellation available to us. Good luck for us. This 9 and 6 both share a factor 3. So that would be 3, and that would be 2 when I divide both those by 3. Now I can multiply them in. This is 3 times 7 on the top is 21, and 8 times 2 on the bottom is 16. 21 over 16 is my answer, and then we're done. Those 21 doesn't have any factors 2, and 16 is just 2 times 2 times 2 times 2. So we're finished. That's that. Now let's try one over here. And like I was saying, you want to also increase your level and increase your ability to do these, right? So be amazed while I do this one in my head. Watch this. It's 3:33. Let's see how long it takes me to do this. 5 over 14. Hooray! So practice, okay? I was not always able to do things like that in my head, but because I've done a lot, I can now, and it's fun. All right. It's also fun to see that check mark because I wasn't 100% sure I was going to get the check mark. I was like more like 95% sure. I figured out the answer, but I didn't check it. Okay. Last skill, mixed operations with rational numbers. Did I pick an example that I wanted to look at over here? I did. Okay, so let's do this. This one is also like, it's really youch, but you could do it on a calculator. And if you can do this on a calculator correctly, that's great. Or you can do it longhand. I'm going to show you longhand and then I'll show you calculator. So this is equal to -3 1/2. So I'm going to convert that to an improper fraction. So that will be -7 over 2 because this is like -6 halves. And then I add the 1 negative half. Both of these things are negative. So it's -7 over 2. Minus minus is actually plus, right? Minus minus here is actually plus. 6 1/4 is 25 quarters. Okay. And then we're going to be dividing by 5.5. Who the heck uses this notation? Not me. I always write it as a fraction. I like this much better. So now we do this addition. I'm not going to use my weird create the common denominator thing. I'm just going to say that -7 over 2 is -14 over 4 plus 25 over 4 divided by 5.5. Well, 5.5 is the same thing as 11 over 2. And your calculator will tell you that is correct. Okay, so now we go ahead and go -14 plus 25. Well, that's 11 over 4. Divided by 11 over 2 is flip and multiply. So the 2 goes on top and the 11 goes on the bottom. 11s cancel. The 2 cancels the 4, but leaves a 2. So this is equal to 1 over 2. Because when I cancel that, I get a 1. 1 is the only thing left on the top. 2 is the only thing left on the bottom. 1/2. Cool. Now, how would you do this on your calculator? Very carefully. Okay, very carefully. This is what I would do. I would copy the question. -3 1/2 plus 6 1/4 divided by 5.5. I remember that I have to do this first because it's in brackets here. See the brackets? So I have to do what's in there first. But here, because I put it in a fraction, it just lives upstairs. So it has invisible brackets anyway. And then I do it, okay? 3 1/2. Yeah, but I say I do it, but then how do I do it? I don't really know how to do. Some of you will have calculators where you can input negative 3 1/2, but like, come on, it's negative 3.5. That's negative 3 1/2. Wait, here, Claire. 3.5, but negative. Okay. Plus 6.25. 6 1/4, 6.25. 1/4, 25 cents. Please memorize that a half is 0.5 and a quarter is 0.25. Okay. And then we go equals. That's what's on top. And we divide that by 5.5. And that gives us 0.5. So the answer is 0.5, which is the same thing as 1/2. Hooray! So that's how these skills, how you practice them. Okay. And if you have any questions about any of these skills, note this one here, you're not going to see a lot of that in 10 applied. That's pretty wild for that level. But the academic level, you want to have that type of skill. Same thing with these compound fractions. Okay. That's going to show up in the academic and university stream. You want that if you want to kind of exceed the standard of the 9 open. But addition and subtraction of fractions is absolutely a skill everyone needs to go forward in math. And you're all going forward in math because most of you want to graduate high school and you'll need 3 math credits to do that. So you need to learn to add and subtract fractions. And that's why I am excited to meet with you, show up for your learning. Thank you for showing up for your learning. If you made it this far, the secret word is ostrich handshake. If you say ostrich handshake to me, I know you got to the end of this video. You can say it in an email. You can say it in the hallway. Bye for now, everyone.